A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. So here's a question that's been bugging me lately. Why is it that when I'm watching a truly devastating film scene, my eyes just start leaking like someone left a tap running? Or when someone tells a genuinely terrible joke, I'm laughing before I've even decided it's funny. My face is doing things my brain clearly didn't authorize. What is happening to us?
That's a beautiful way to frame it, and honestly, this is one of those topics where the answer is far stranger than the question itself. The short version is that these seemingly nonsensical physiological reactions are actually incredibly sophisticated social signaling systems that evolved over millions of years. But the mechanism is where it gets genuinely fascinating.
Right, because we could have just, told each other we were happy or sad. Words exist, language exists, but instead we evolved to just kind of leak from our face holes. That seems like a design flaw.
It only seems that way because we're looking at it backwards. Recent research from Reich can actually flip the causality on its head. It may not be that we smile because we're happy. It might be that we're happy because we smile. The brain mechanisms are more complicated than the folk wisdom suggests.
Wait, so you're telling me I can just decide to smile and then I'll become happy? That sounds like something you'd see on a motivational poster in a dentist's office.
The science is more nuanced than that, but also basically yes. When you activate the muscles involved in a genuine smile, specifically the orbicularis oculi around the eyes combined with the zygomaticus major that pulls the mouth up, something physiological happens. A 2023 meta-analysis in Nature Human Behaviour analyzed 43 studies involving over 11,000 participants and found that these Duchenne smiles correlate with a 12% reduction in cortisol levels. So the facial configuration itself is sending signals back to your brain that change your internal state. But here's the nuance. The effect was strongest when participants genuinely smiled rather than just posed for a camera. There's a difference between contracting those muscles because you're feeling something and contracting them because someone told you to.
Interesting. So the face isn't just reporting what the brain is feeling, it's having a two-way conversation with it. Like the brain and the face are texting each other back and forth.
That's a useful framing. The facial feedback hypothesis has been around since Charles Darwin and William James were debating it in the 19th century, but the modern neuroscience is finally showing us the mechanism. When you contract those specific muscles, you're activating sensory fibers in your face that directly influence the limbic system, particularly the amygdala, which processes emotional salience. The trigeminal nerve carries this feedback up to the brainstem and into regions that regulate mood and stress response. The face isn't just an output device, it's an input device too.
Okay, but that still doesn't explain why we evolved to do this in the first place. There had to be some survival advantage to just randomly baring our teeth at each other or making weird honking sounds when amused.
And this is where it gets really interesting. There's a theory called the defensive mimicry hypothesis, developed by Michael Graziano and published in 2022, that suggests smiling, laughing, and crying all evolved from defensive reflex responses. Think about what happens when you're threatened. Your face tenses up in a very specific way. Your mouth opens. Sometimes you make sounds. These were originally protective responses that helped the body prepare for impact or expel irritants. Even in our primate cousins, you can see elements of this. Chimpanzees open their mouths wide when they're uncertain about a social situation, and this baring of teeth can signal either submission or the beginning of friendly interaction depending on context.
So we're basically expressing emotions with our face, using the same machinery we use to prepare for getting punched.
In a sense, the theory proposes that these defensive responses got co-opted over evolutionary time for social communication. An animal that showed its teeth in an aggressive display was already halfway to a smile. A creature that made noisy expulsion sounds during distress was already halfway to crying. The same physiological machinery got repurposed, and here's the key part. These expressions became so useful for social coordination that they actually became innate. We don't learn to smile or cry. Infants are doing it within weeks of being born. Monkeys raised in isolation, never having seen another face smile, still make facial expressions that look remarkably like smiles when they experience positive states.
Pre-social smiling, right? I've heard about this. Infants smile around 6 weeks old, long before they could possibly have learned the behavior from watching others.
That's critical evidence for the innate wiring argument. You can't teach a 6-week-old to smile. They haven't accumulated enough social experience to understand what smiling means in a cultural context, but they're doing it anyway. This points to deep evolutionary programming rather than cultural acquisition. Researchers have documented this by studying blind infants who have never seen a human face, and they develop the same facial expressions at the same developmental stages as sighted infants. The smiles and frowns and cry faces emerge on schedule, completely independent of visual social learning. The social smiling we learn later, the polite professional smile you give to someone you don't particularly like, that overlay comes later. But the raw emotional smile, the Duchenne smile, that's pre-programmed.
So there's a difference between the smile I give my brother when I'm genuinely glad to see him, and the smile I give my dentist when he's digging around in my mouth with sharp objects.
Massively different, and critically, other humans can tell the difference almost instantaneously. The Duchenne smile involves the orbicularis oculi muscles. When you're genuinely happy, your eyes crinkle at the sides, the cheeks lift. The whole face participates. A social smile, the kind you give as a learned social nicety, typically only activates the zygomaticus major. The mouth moves, but the eyes stay flat. This is why people are so good at detecting insincere smiles. We've evolved to read these signals because they tell us something vital about whether someone is friend or foe. Some researchers estimate we're accurate about this about 75% of the time, which sounds low until you consider how complex and ambiguous most emotional signals are.
Because, in evolutionary terms, a genuine smile was probably a signal that said, I'm not a threat. You can approach me. We can cooperate. Whereas a fake smile meant someone was concealing hostile intent.
That's exactly right. The smile became a trust signal, and the same logic applies to laughter. When you laugh, you're essentially signaling to others in your group that whatever triggered that response is safe. If something is dangerous, you don't laugh at it. You freeze or flee or fight. Laughter is the sound of the nervous system saying, false alarm, stand down, we can relax. This is why laughter is so contagious. We're wired to respond to other people's laughter as evidence that the environment is safe. There's even research showing that just hearing recorded laughter can prime people to find things funnier. Your brain hears the signal that says danger is low and adjusts your emotional baseline accordingly.
And crying? What was crying originally for?
Crying is more complex, but the defensive mimicry framework offers an interesting interpretation there too. Crying involves the vagus nerve, which connects the brainstem to the heart and lungs. When you cry, you're activating the parasympathetic nervous system, which slows your heart rate and helps your body recover from stress. So crying isn't just signaling distress to others. It's actually a physiological reset mechanism for your own body. You're releasing stress hormones like cortisol through the tear fluid. You're activating the vagal brake that calms your nervous system down. There's actually some evidence that emotional tears are chemically distinct from the reflexive tears that clear irritants from your eyes. Emotional tears contain more stress hormones and proteins, suggesting they're doing actual physiological work.
So crying is like your body hitting a reset button after an emotional overload. That actually makes a lot of sense. It explains why you often feel better after a good cry.
And this is something that gets misunderstood culturally. People think crying is a sign of weakness or an inability to cope, but the physiology suggests the opposite. Crying is an active coping mechanism. Your body is doing something constructive. The tears themselves contain stress hormones that are being expelled from your system. It's not collapse, it's regulation.
I've definitely heard people say they needed to cry to release tension. That tracks with what you're describing.
The vagus nerve connection is key here. When you cry, you're not just producing tears, you're triggering a cascade that affects your heart rate and breathing. The vagal response is what creates that characteristic feeling of being emotionally wrung out, but also relieved. Your body has literally been through a physiological process, not just an emotional one. There's actually evidence that crying triggers the release of oxytocin and endorphins, the same bonding and pain relief chemicals involved in social bonding and comfort-seeking behavior.
Okay, so we've got smiling, laughing, crying. All of them evolved from defensive reflexes but got co-opted for social signaling, and all of them have feedback mechanisms that influence our internal states. What else is happening neurologically? You mentioned the limbic system earlier.
The limbic system is the emotional processing center of the brain, and it's deeply involved in generating these expressions. The amygdala assesses the emotional significance of what's happening in your environment. When it detects something relevant, it triggers a response through the hypothalamus, which then activates the autonomic nervous system. The autonomic nervous system controls the physical aspects of emotional expression. It determines whether you get the fight or flight sympathetic response or the rest, and digest parasympathetic response that we see in crying. But there's also the periaqueductal gray in the midbrain that coordinates the vocalizations associated with laughing and crying. This is why these expressions are so automatic and so hard to consciously suppress. You're dealing with very old brain structures that predate complex cognition.
And this all happens automatically, without conscious input.
Largely. The pathway from sensory input to emotional expression can be processed in the amygdala before the signal even reaches the cortex where conscious thought happens. This is why you can react emotionally to something before you've consciously figured out what it is. Your brain has already made an assessment and triggered a physiological response. The conscious awareness comes slightly later, like about a quarter second later, which in neuroscience terms is actually quite significant. By the time you're thinking about your reaction, your body is already expressing it.
That explains why someone can tell a joke and I'm already laughing before I've even processed whether it's funny. My amygdala just said, "This is safe social interaction, trigger laughter," and my body obeys.
And this is where it gets relevant for the modern world. In an era of digital communication, we're losing access to most of these signals. Text messages and even voice calls strip away enormous amounts of emotional information that evolution prepared us to communicate and receive. We've spent most of human history reading faces and bodies and vocal tones. Now we're trying to communicate emotional content through emoji and punctuation.
Don't even get me started on people who text in lowercase because they don't want to seem emotional. Your phone is just sitting there emitting pure lowercase letters with no facial expression. I have no idea if you're happy, sad, or about to murder me.
The research on this is pretty bleak. Studies on emotional accuracy in text versus face-to-face communication show that we lose something like 80% of emotional nuance when we remove visual and tonal cues. We're running our social cognition on a severely degraded signal. This is part of why digital communication leads to so many misunderstandings. We simply don't have enough information to accurately read each other's emotional states. Some researchers have started calling this emotional bandwidth and arguing that we're operating with a fraction of the communication capacity that humans evolved with.
And yet, we've somehow built an entire economy around remote work and digital interaction. Everyone's just navigating this impoverished emotional landscape and pretending it works.
To some degree it does work, because we're remarkably good at filling in gaps. We're pattern completing, using the same machinery that helped our ancestors detect predators in the grass to infer emotion from text. But it's cognitively expensive and error-prone. This is why video calls are so much more exhausting than in-person interaction. You're working harder to read emotional signals that your brain expects to receive more directly. The slight delays, the compressed visual field, the inability to see someone's full body language, all of these add up to cognitive load that your brain wasn't designed to handle for 8 hours a day.
So what happens when we layer AI into this? Because AI systems are now trying to recognize and respond to human emotions. That seems like it could go very wrong very quickly.
That is already happening, and the results are mixed in ways that illuminate how complex these systems are. There are companies like Affectiva that have been working on emotion recognition, AI, for over a decade. Their systems analyze facial movements and vocal patterns to infer emotional states. The technology has gotten quite sophisticated, but it still struggles with fundamental issues. Cultural variation in expression norms is one major problem. Research has shown that people from different cultural backgrounds express emotions differently. Some of the basic assumptions built into emotion recognition systems come from studying Western populations and may not generalize.
Because in some East Asian contexts, for instance, a smile might express discomfort or embarrassment rather than happiness. If your AI doesn't know that context, it's going to misread the signal completely.
That's exactly right. And even within a culture, people are highly variable in how they express emotions. Some people cry more easily than others. Some people's laughter is more subdued. The AI systems often perform better on average than individual humans, but they can also fail in ways that no human would. They miss the context. They don't know what's happening in the broader situation. They see the expression, but not the story. There's a famous case where an emotion recognition system used in job interviews flagged a candidate as unengaged because they happened to have a facial structure that naturally made their eyes appear partially closed. The algorithm had no way of knowing this was just their face.
But here's what I find really interesting about this. We've been talking about how expressions influence our internal states. What happens if we could deliberately engineer that? Could we essentially hack our own emotions through our faces?
There's actually good evidence that we can, to some degree. The research on facial feedback I mentioned earlier shows that manipulating your facial expression can influence your emotional state. There's been some fascinating work with Botox. When people get Botox injections that paralyze the muscles involved in frowning, they report reduced intensity of negative emotions. The inability to furrow your brow seems to make it harder to feel as angry or distressed. The feedback loop is broken. One study found that people who had Botox injections in their frown lines showed reduced amygdala activity in brain scans when shown negative images, compared to a control group. The brain simply wasn't getting the same feedback that would normally amplify the emotional response.
So if I want to feel happier, I should just smile more.
The evidence suggests yes, with some caveats. A genuine smile, a Duchenne smile, seems to be more effective than a forced smile. But even a forced smile can have some effect, probably because you're partially activating the same muscle patterns. The key is that you're providing your brain with proprioceptive feedback that says, this is what a happy face looks like. The brain integrates that information and adjusts your emotional state accordingly. There's even research showing that holding a pencil in your teeth to simulate a smile makes things seem funnier. The body is contributing to the experience even when the smile wasn't generated by a genuine emotional state.
That's almost like cognitive behavioral therapy, but through your face. Instead of changing your thoughts to change your feelings, you're changing your face to change your feelings. Same general principle, different delivery mechanism.
That's a nice way to put it, and it suggests practical applications. If you're in a stressful situation, deliberately smiling, genuinely smiling, can actually reduce your physiological stress response. The cortisol reduction from a Duchenne smile isn't trivial, it's measurable. You can use your own facial expressions as a tool for emotional regulation. This is actually something that actors know intuitively. Method actors who fully inhabit emotional states through their bodies often report genuinely feeling those emotions, not just performing them. The technique becomes a portal to authentic internal experience.
Okay, so practical takeaways so far. 1. Pay attention to the difference between your genuine smiles and your social smiles. When you're trying to manage your own emotional state, go for the real one. 2. If you're reading other people's emotions, don't rely on a single signal. Look for clusters: facial expression, body language, context, vocal tone. 3. Crying is actually your body doing something constructive, not something broken. Don't judge yourself for it.
Those are all solid. I'd add one more. In digital communication, be aware of the impoverished signal you're working with. If you're trying to communicate something emotionally nuanced, consider whether text is the right medium. Sometimes, a 30-second voice note or video call carries information that would take paragraphs to approximate in text. And when you receive a text that seems cold or hostile, consider that you might be filling in negative information that isn't actually there. The brain is pattern completing, and it doesn't always complete in the generous direction.
And if you're building AI systems that interact with humans, remember that emotion recognition is genuinely hard because the training data probably doesn't represent the full diversity of human emotional expression. These systems have blind spots. If you're training on data from a narrow population, your system will fail on everyone else. It's not just an accuracy problem, it's an equity problem.
One thing that strikes me about this whole topic is how much we're still discovering. The Riken research is rewriting our understanding of the causal relationship between expressions and emotions. The defensive mimicry hypothesis is relatively new and offers a coherent framework that explains features of emotional expression that older theories couldn't. We're in a period where the neuroscience is catching up to what philosophers and psychologists have been debating for centuries. Darwin wrote about emotional expressions in animals and humans in 1872, and he got a lot right, but we're finally able to test his intuitions with modern brain imaging and physiological measurements.
So, where does this go next? As we spend more time in digital spaces, are our expressions going to evolve?
That's a genuinely open question. We've already seen some evidence that people who spend more time online develop different patterns of emotional expression in digital contexts. They might be more expressive in text or develop unique vocabularies for conveying tone. But whether this represents actual evolution or just cultural learning is hard to say. The timescale of evolution is much longer than the timescale of technological change. What we're seeing is probably mostly behavioral plasticity, humans adapting their communication strategies to the medium. But there could be subtle neurological adaptations happening over generations if certain expression patterns become more or less useful.
But in virtual reality and augmented reality, where we might have avatar faces that can be more expressive than our own biological faces, what happens then?
That's fascinating territory. If your avatar can smile more expressively than your real face, or if you can modulate your avatar's expressions in ways you can't physically do, does that change the emotional dynamics of interaction? Some research suggests that people actually prefer interacting with avatar faces that are slightly more expressive than real human faces. We find that comfortable because it matches something our pattern recognition expects, but slightly exaggerated. It's like the uncanny valley, but in the positive direction. But there's a risk that we become dependent on that augmentation and lose skill at reading real faces, like how GPS has made many people worse at navigating without assistance.
So we might be moving toward a world where the emotional grammar of facial expression is augmented by technology. Our biological signals get amplified and transmitted more clearly. That could be genuinely transformative for digital communication.
Or it could create new problems if the augmented signals become divorced from genuine internal states. Imagine everyone walking around with perfectly curated avatar faces that never reveal anything authentic. We've already partially solved that problem with text by inventing sarcasm and irony and all the other layers of metacommunication. Avatar faces might just add another layer. We'll develop new heuristics for telling the difference between authentic and performed avatar expressions, just like we've developed heuristics for distinguishing genuine smiles from polite ones. The cat and mouse game of emotional deception and detection will continue, just at a higher fidelity level.
That's a bit dystopian. We'll save that thought for a future episode.
Speaking of future episodes, Daniel sent us a prompt about exactly this territory recently, so maybe we'll circle back.
We should. But for now, let's bring this home. The bottom line is that our emotional expressions are non-arbitrary or nonsensical. They're sophisticated, evolved communication systems that evolved from defensive reflexes, got hardwired into our nervous systems, and now operate as two-way signals between our faces and our brains. They're so embedded in our biology that manipulating them can change our emotional states, and they're so socially crucial that we feel their absence acutely in digital communication. Understanding them makes us better at reading other people, better at managing our own emotions, and better at designing technology that respects how humans actually work.
And that feels like something worth knowing.
Agreed. Thanks as always to our producer Hilbert Flumingtop for keeping this operation running. Big thanks to Modal for providing the GPU credits that power this show. This has been My Weird Prompts. If you're enjoying the show, a quick review on your podcast app helps us reach new listeners. We'll see you next time.
See you then.
This episode was produced using Minimax M2.7. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the flows from sloth.